Hello everybody, welcome back. This is section 8.2 of chapter 8, Acids and Bases. And what we're going to do is we're going to look at the strengths and how we measure how strong or weak an acid is. So I'm going to select my pen so I can do some annotation. I finally remembered how to do that. Okay, so a strong acid is something that completely ionizes in solution. What that means is that everything that comes from the hydrochloric acid, is going to dissociate or become the chloride ion and the hydronium ion. A weak acid, just like it sounds, dissociates only slightly in the water. So what happens is, like in the case of carbonic acid, which is a weak acid, when you put it in water, it dissociates into the hydronium ion, but it also has the bicarbonate ion. Okay, so it's not completely dissociated. And so this is a reversible reaction. Notice we always draw that by having those arrows go both ways, whereas when a strong acid goes, it goes completely that way, right? So it goes completely to the right. So a strong acid is going to completely ionize, but a weak acid will dissociate only slightly. And so in addition to the hydronium ion and the carbonate, you're still going to have some of that carbonic acid in there. So in water, the dissolved molecules of a strong acid dissociate 100%. They give a large quantity of your hydronium ions and the anion that was associated with that acid. So as we saw in the case of hydrochloric acid plus water, you get the hydronium ion and then the chloride ion completely, 100%. So there are 6 strong acids, okay? And remember that if this is the rule, if you have a strong acid, you're going to have a weak conjugate base. Okay, so that's something to remember. If you have a strong acid, it's going to go completely to the right in the reaction, and so you'll have a weak conjugate base. So there are 6 of these: hydroiodic, bromic, perchloric, hydrochloric, sulfuric, and nitric. Okay, so those are your strong acids. So everything else is a weak acid. So if you know these 6 strong acids, then you don't have to worry about memorizing the weak acids, because you just know everything else is weak. In a weak acid, as we said, you still have some of the acid left, in addition to the hydronium and the anion. So this is called the molecular form of the acid, and it just hangs around, and that's just how weak acids dissociate. And again, we used the example of the carbonic acid, which is a buffer, and that's a whole other story that we'll talk about a little bit later. So weak acids make up most of the acids, and so I've already given you the 6 strong. The weak acids are all the rest of them, okay? But if they're a weak acid, sorry, I'm still working on this. Weak acid, you're going to have a strong conjugate base. So just remember they're the opposite. In a hydrochloric solution, which is one of the strong acids, it's going to dissociate 100%. In a carbonic acid, so it's going to look like this, completely dissociated. But in the carbonic, you're going to see some of the original acid, some of the hydronium, and some of the bicarbonate ion. Just kind of showing you what it looks like in a picture. So there's just the table that's in your book. So, but just remember what I told you, is if you memorize the strong acids, there's just 6 of them, then everything else is weak. Strong bases are formed from metals of group 1A and 2A, which are the far left of the periodic table. Okay, and they're going to dissociate completely in water as well. But remember, they're going to be hydroxides, and so they will dissociate by separating the potassium and the hydroxide into the potassium ion and the hydroxide ion. Because Arrhenius defined bases, if you recall, as something that donates an OH or produces an OH. So let's identify each of the following as a strong or a weak acid or base. HBr, HNO2, sodium hydroxide, H2SO4, or cupric OH or hydroxide. So pause me if you need to and look at these and then tell me what's up. Okay, welcome back. Let's see how we did. So basically all you had to do, if you hadn't memorized them yet, is look on the chart, right? And so that's not too hard. So your strong acids in this list were the sulfuric acid, which was D, and the hydrobromic acid, which was A. Weak acid was nitrous acid, and then our bases, sodium hydroxide. Okay, because remember, sodium is in the group 1A or 2A, so it's going to make strong. Everything else is going to make a weak hydroxide base. Which one is stronger? Again, you can look at that table, and it shows you from weak to strong as you go up that table, and so you can tell if it's above it, then it's stronger on the list. There you go. All right, and that was a really quick section. That's the end of 8.2. I hope you enjoyed it, or at least it wasn't too painful, and I will see you for 8.3.